Hello students, good morning. Today we are in second chapter, and this chapter name is polynomial, and we are going to describe the polynomial. Polynomials are algebraic expressions of the form of px equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 a3 x to the power n minus 3 up to an x plus an, where a0 is not 0 is called polynomial in variable x of degree n, where a1, a0, a2 are the real numbers and constants. Each power of x is a non-negative integer. For example, 13x plus 5, 19x square plus 5, x plus 8, etc. So how we will check the polynomial? Given expressions are polynomial or not? See this example. 1 px is given 19x square plus 5x plus 8. Here the algebraic expression has variable has x positive integral power, so it is polynomial. Second, 19x square plus 5x plus 8x, 5 root x. Root x means x to the power half. It is fractional power, so it is not polynomial. Third, px equal to 2x cube plus 7x square minus 5x plus 7 upon x. Here 7 upon x means 7x to the power minus 1. Variable x has negative power, so it is not a polynomial. Now after this, here four expressions are given to you, and you have to recognize whether these are polynomial or not. These you will do in copy. Second, degree of polynomial. You are aware that the polynomial, in a polynomial, the highest power of x is called degree of polynomial. Consider the polynomial 6x cube plus 11x square minus x plus 90. Here the highest power of the variable x is 3, so degree of polynomial is 3. Few practice questions are here. You have to find out the degree of polynomials. So you will see the highest power of x, that will be degree. Now we can classify the polynomials based on degree. The polynomial whose degree is 0, constant polynomial. Linear polynomial is that polynomial whose degree is 1, example 2x plus 3. Quadratic polynomial whose degree is 2, ax square plus bx plus c equal to 0 type polynomial is quadratic. In a similar manner, cubic polynomial is a polynomial whose degree is 3. For example, 8x cube plus 9x square plus 2x plus 3. Biquadratic polynomial whose degree is 4. And algebraic expression of the type 7x to the power 4 plus 9x cube plus 5x square plus 2x plus 3. This is the example of biquadratic polynomial. Here 4 graphs are given, in which the first graph is constant polynomial because its height is constant from x-axis. This is linear polynomial. It is forming straight line. And the third, this is quadratic polynomial. There is only one bend. This is cubic polynomial. In a similar manner, we can form the biquadratic polynomial also. and this is biquadratic. 1 2 3 4 degree polynomial. This way we can see the shape of the polynomial in the graph. The polynomials we can classify on the basis of the terms also. First, monomial. A polynomial having only one term is called monomial. For example, 7x. Binomial, a polynomial having two terms. For example, 6x plus 3. Trinomial is also there, having three terms. And the polynomial having more than 3 is called multinomial. These are the examples given here. So many polynomials having 3 terms, and having more than 3 terms is called multinomial. Now, value of polynomial at given point. Whatever the real number is given, you can put in place of x in the polynomial and you will get its value. For example, here px is given 6x cube, px is given 6x cube plus 11x square minus x minus plus 90. Putting x equal to 1, we will get the value 106. This is value of polynomial. So few questions are here in which you have to determine the value of x. Px is given and in front of polynomial the value of x is given. You have to determine value of x at that particular real number. Next topic is here that zeros of the polynomial. A real number x equal to a is called zeros of the polynomial, which makes polynomial 0. If we put x equal to that particular real number which is given, and if it gives 0, then it is called zeros of the polynomial. In graph, the intersection of the polynomial and the x-axis denote the zero of the polynomial. This graph is given here. Here, this is constant polynomial because its height is constant and it is not intersecting x-axis, so it has no zero. This one is linear polynomial. It is cutting x-axis at on one point, so it has 1 0. This is quadratic polynomial, touching x-axis only, so it has 1 0. This is also quadratic polynomial, but it is not cutting x-axis, so it has no 0. This is also quadratic, cutting at 2 points, so it has 2 0. It is quadratic polynomial. This is also quadratic polynomial. In a similar manner, cubic polynomial is also there. Cubic polynomial shape is like this. It is cutting at 3 points, so it has 3 zeros. Now, one question is on the basis of this, you have to classify the types of the polynomial and the number of zeros, and the value of these zeros you have to determine. In this graph, constant polynomial, this is constant polynomial and it is not intersecting x-axis, it has no 0, and This one is linear polynomial. At one point it is intersecting at one point, and it is cutting at -1, so -1 is 0 of the polynomial. This one is quadratic polynomial. This quadratic polynomial is cutting it at 2 point, -2 and 2, so it has two zeros, and the value of zeros is -2 and 2. This is also quadratic polynomial. It is cutting at -1 and 2, so it is quadratic polynomial, and the value of zeros are -1 and 2. After this, two more graphs are here. One is cubic polynomial. It has 3 0 because it is cutting 3 at 3 points. These points are -2, -1 and 3. These are the value of zeros. And this one is by quadratic polynomial, and it is cutting at 4 points x-axis, so these are the, which has 4 zeros, and the value of these zeros -3, 1, this is 3, and this is 7. These are the points, and these are the zeros. This way you will recognize the value of zeros, type of polynomial, and number of zeros using this graph. Students, I hope that you will understand it, and you have to write all these definitions and sheets in a fair copy, and whatever the practice questions are given to you, those you have to solve. I think you will follow all the instructions. Thank you. Have a nice day.